Rajiv here from Math Vibes, and this is part 2 of simultaneous equations using the elimination method.
Oh my god!
If you didn't already, go check out part 1 to find out who was the father. That being said, let's move straight on to the example. Case 2, elimination with two linear equations. Now this is very similar to case 1, but there's a bit more working that needs to be done. So we're going to try to get rid of x. Now, if we want to get rid of x, we are looking to see if the x terms in equation 1 and in equation 2 are the same or if they are the opposite. Remember, if they are the same, you would subtract, so they would cancel off. And if they are the opposite, you'll add them so that the opposites would cancel off. So in equation 1, we have 2x, and in equation 2, we have 4x. Is there anything you could do to make the x term here and the x term here the same? The answer is yes. All I have to do is multiply throughout by 2 in equation 1. So that 2x is going to turn to 4x, that 3y is going to turn to 6y, and that 12 is going to turn to 24. And I'm going to call this equation 3. I'm going to write back equation 2 as well. And equation 2 was 4x minus 3y is equal to 6. And this was equation 2. Now guys, let's look at equation 3 and equation 2. Aren't they the same now? So if you have the same, all you have to do is subtract so that they would cancel off. So 4x minus 4x is 0, right? We get rid of x. Then we have positive 6y minus 3y. So what does that come like? That comes like we have plus 6y minus 3y. Now our minus by minus is a plus, so we're going to get plus 6y plus 3y. And what is 6y plus 3y? That is 9y.
Boom.
Right, so this is going to be plus 9y, and 24 minus 6 is 18. And so we end up with 9y is equal to 18. So if 9y is 18, then y would have to be 2, because 9 times 2 is equal to 18. So you could have just wrote y is equal to 2. But the full working would be to divide both sides by 9. So you would find for 1y, right? 9 into 9 is 1, so that's 1y. And 9 into 18 is 2 times. So we get y to be equal to 2.
Boom.
So that was really simple, right? And so let's try to find for x now.
Here we go again.
To find for x, you can use equation 1, equation 2, or equation 3 if you wanted. So equation 1 was 2x plus 3y is equal to 12. And now I know that y is equal to 2. Anywhere I see y, I could just write 2. So I'm going to write 2x plus 3 by 2, and that'll be equal to 12. Now, what is 3 by 2? 3 by 2 is 6, and that'll be equal to 12. Now, if we are trying to find for x, then I want to isolate x. So I'm going to leave 2x on the left-hand side, and I would move across all of the numbers or the constants. This is a constant. All numbers are constants. And so I'm going to move across 6. If I move across positive 6, it's going to turn to minus 6. And so I'm going to end up with 2x is equal to 12 minus 6. And 12 minus 6 is equal to 6.
Boom.
And so we have 2x is equal to 6. So what do you have to multiply by 2 to get 6?
Huh?
The answer is 3. The full working would be to divide both sides by 2. The 2 and the 2 would cancel off. 2 into 6 is 3, so x is equal to 3. Awesome. And that's not the only way you could have found for x. You could have also used equation 2 or equation 3. Let's do it fast with equation 2. So that's going to be 4x minus 3y is equal to 6. And remember, anywhere you see y, you're going to replace it with 2. So that's going to be 4x minus 3 by 2 equal to 6. What is minus 3 by 2? That'll be minus 6 equal to 6. If you are trying to find for x, you want to leave 4x on the left-hand side, and you want to move across all of the numbers. So let's move across minus 6. If you move across minus 6, it's going to be 6 plus 6, and that's going to be 12. So what do you have to multiply by 4 to get 12? The answer is 3. So x is equal to 3.
Quick math.
Or you could just divide both sides by 4 to find for 1x. 4 into 4 is 1. So 1x would be equal to 4 into 12. That's 3. And again, you saw that we got the same answer.
Let's go.
So in the exam, when you find for one of the unknowns, you can choose to use either equation 1 or equation 2. Doesn't matter. If you want to flex, you could do both. If I wanted to check if my answers are correct, the value is supposed to satisfy all the equations. So let's quickly see if it satisfies equation 1 and equation 2. So remember, equation 1 was 2x plus 3y is equal to 12. And so if I plug in my values for x and y, it's supposed to give me 12. So we found that x was equal to 3, and we found that y was equal to 2. So I'm going to write 2 by 3, because x is 3, and I'm going to write 3 by y is 2. If I'm correct, it's supposed to be equal to 12. So let's see if that's the case. 2 by 3 is 6, 3 by 2 is 6, and what is 6 plus 6, guys? 6 plus 6 is 12. So because we're getting 12 is equal to 12, you know that you're correct. Let's see if it'll satisfy equation 2 now. So equation 2 is 4x minus 3y is equal to 6. Remember, x is 3, y is 2, and so if it's correct, it's supposed to give us 6. What is 4 by 3? 4 by 3 is 12. What is 3 by 2? That's 6. So 12 minus 6. And what is 12 minus 6, guys? That's 6. That means our answer is correct. So your answers are x is equal to 3 and y is equal to 2. If you wanted to write the answer as a coordinate, remember it's x first, then y. So you'll write 3, 2. And this represents the point of intersection if I plot the graphs. Now let's look at the graphical interpretation. If I were to plot these two graphs, obviously I'll get lines because they are linear equations. Linear line. Line.
Nice.
It's in the name, guys. And so if I plot the graph for 2x plus 3y is equal to 12, I get that. And if I plot the graph for 4x minus 3y is equal to 6, I get that. I want you all to observe where they intersect. They intersect at this point over here. And if we were to take a read off, x is 3 and y is 2. And that's the same answer we got when we did it using the elimination method.
Understand that?
So anytime you have a system of equations and you want to figure out what values satisfy all of them, you can just simply do a sketch and see where they intersect. And why is the intersection giving us the answer?
Huh?
The intersection is giving us the answer because at the point of intersection, that point lies on both of the lines. And if it lies on both of the lines, then it will satisfy both of the equations. And we saw that when we were trying to prove if our answer was correct, remember? Because if you plug 3 and y into both of these equations, you'll get 12 here and you'll get 6 here. So I hope you learned something new. Thanks for watching, and don't forget to like, follow, and comment. I will do a part 3 showing how to get rid of y, so stay posted, guys. Later.
I will beg on the road for $1 or $2 on the road, but I ain't gonna rob nobody.